Welcome to this session on blocks and events. In this session, we'd like to define what is a block. We'll look at how to create custom blocks, and then we'll look at the types of interactions our blocks can have. And our blocks can interact by triggering events that will be handled by the parent, which means the parent has to have event handlers defined as actions to be able to react to these events. And overall, the blocks will have and behave as part of the overall screen's life cycle. And that may include reacting to parameters that change when coming from the parent. So let's go ahead and look at this in a little bit more detail. So what is a block? A block is a container that defines a custom-built screen component. A block could hold widgets and patterns or other blocks, and we can build them in any way we want to define a brand new custom-built screen component. Once that component is built, it will need to be able to respond to lifecycle events. So a block is just like a screen in the fact that the block has an onInitialize, onReady, onRender, and onDestroy. And these blocks can be placed inside of screens or inside of other blocks. And regardless of whether it's in a screen or a block can receive input from its parent. And if the input from the parent changes over time, it will receive an event, an onParameters_changed event, and then we can define an action for how to respond to this particular type of event. And then our block can also define and trigger events itself to notify the parent of things that have happened. So let's look at a practical example. Let's look at our ToDos, and we have a ToDos list screen. And here we're looking at the to-do list screen that has a to-do block in it. So we can see that we were using the common layout. We had created a list. That list has a list item. And inside that list item, we're using a to-do block. And this custom-built offline to-do block is here inside of the screen. So when we look at the definition of a block, we can tell what the source or what type of block that is, and then what type of input that block needs. And in this case, the input for this block is a to-do, and this to-do is going to go ahead and be retrieved using this aggregate to go ahead and get the to-dos and bring them back. We can also see more information about the events, and we'll talk about these in just a second. But we can see here that the list screen is including a block inside of it, and this block is trying to define what it can do. Here we don't see that definition, although we're seeing the to-do block. Because it's in this screen, we're actually looking at what the screen is worried about. The type of block it is, the type of input it needs, and the types of events that it can throw to this screen. And then we can define the screen handlers, which we'll come back and look at in just a second. So we worry about the name, the source block, and then really the events and the handlers when we think about the parent. So when we place the block on a screen, it's the parent's definition that's really being inspected. Now if we want to see the to-do block itself, we would go inside of the user interface area, and here we can see the definition of the to-do block. It is taking the input that we just mentioned, which is a to-do entity, and we can see that this to-do block has the ability to throw an event called priority change and another one called star change. And this is because people may be able to click on our priority or click on the stars and change whether or not they think it's a starred to-do and what the priority of that to-do should be. When they change these, it will throw the event. Now, these events are defined here, but to be able to throw that event, when we actually click on a star, the star will have the star on click action, And inside of this action, we could go ahead and throw that particular type of event. So if we look at the type of change that can occur there, that's not the only type of change that can occur. The other thing that can occur is that this input variable will change at some point. And if this input that was given to us originally, so here we can see that design an app for movies was probably the title of this to-do. And the due date is null because it's giving us January 1st of 1900. But there was data coming in to this particular block. If that data were to change because the data is coming from the parent, then we could define an action here in onParameterChanged to define what to do when that occurs. If we define nothing to do, then after the screen originally renders, we will not actually do anything when that piece of data changes because we have nothing to react to the change. So this is a very important action because this event that will be thrown as part of that overall life cycle, if we don't have that action, then we can't react to changes in the to-do that was our input. Now, inside of our to-do, if someone clicks on the priority icon and changes that priority, here you can see that we would go ahead and assign a new priority to it, update the local storage with that information to make sure that the to-do's new priority is stored, and then it could throw the priority change. And when we say throw or trigger, this event will be triggered, and that will allow the parent to go ahead and react to that if necessary. And what would happen there is, because this priority change event would have been thrown, the parent would then use its to-do priority change handler. And in this particular case, because we may have done a sort, and if we went ahead and changed this, so maybe we're currently looking at all of the low priority tasks, and if we change this to a medium priority, then it should change this particular list and redraw the list and refresh the data so that this medium priority task would be removed because we're only looking at the low priorities. So that's the type of interaction that can occur. Now, we have been mentioning that onParameterChanged is an event that is sort of occurring inside of the mobile screen lifecycle. And we tried to show a little bit of that, but there's a slightly better way to kind of think of this. If we look at the onParameterChanged event, this event is only available for blocks. And it will occur whenever the parent changes any of the inputs that would occur for that block. So again, going back to our to-do example, the to-do has this entity that is the input structure, and if that were to change, then we could go ahead and use an action. And sometimes that action might do something like recalculate variables, refresh the data so that we have the latest data given the fact that something here may have changed. So this gives us the ability to know what's happening inside the block, and we can go ahead and react as needed. So let's look at an example. Why might this happen? Well, here we have a block, and the block is drawing a graph. This graph may be from a particular time to an end date, or with some sort of different type of input and variable. But let's use date as the example. So if it's going ahead and drawing the graph to a particular date, and we change the date is not inside the block. The date was being passed into the block from the parent. When this parameter changes, it goes ahead and it notifies the block. The block's parameter changed action that is attempting to handle that is supposed to refresh the expenses. So as soon as this happens, the block renders because it realizes that there is a change, but at the moment the onParameterChanged event went to get new data. So at this point, it doesn't have anything that is new or different, so it stays the same. The screen, because one of the values on the screen changed, the screen will also render. And when the screen renders, that may change other things inside of the screen. In this case, it just changed the date, so there wouldn't be any significant difference. And then when the getExpenses comes back and runs the onAfterFetch, this will now have all of the new data, and because the data inside of the chart has changed, it will re-render the block again. And at this point, we'll get the new data and see things have changed. So although the block is rendering the graph, we can go ahead and have inputs and data from the screen, that is the parent, that will go ahead and affect it. It may not affect it immediately, depending on the type of action and the work that we do, but it still can go ahead and affect it. And the reason for this strange life cycle, or the reason it doesn't react immediately, is because of these asynchronous requests to go ahead and get the data and update things. So, in summary, we looked at what a block is. We looked at the fact that we'll use blocks to go ahead and create custom screen components. And then we began trying to walk through the interactions that occur between the parent screen or parent block and the block itself, where we may need event handlers to handle actions, and we will be able to trigger those events as needed. And the mobile life cycle of the screen is a little bit different, and we have this capability in blocks to do onParameterChanged. So that's it for this session on blocks and events.